Here we are in section 5-5 with exercises 26 through 29. Here we are with word problems. We've got these word problems. We're going to try to create a math equation, and that equation will be a polynomial, so we can use our newfound tools. A cone has a surface area. Okay, so we got to find the surface area formula for a cone of 36 pi centimeters square and a slant height. The symbol for that was the L. Of 9 centimeters. What is the radius of the cone? See the appendix for the formulas. If you look back to the appendix, you should get the formula. SA equals pi r squared plus pi rl, with L is the slant height. So the surface area, that's the stuff on the bottom, and that's the lateral surface area on the side. So let's put everything in that we have. 36 pi. Some of you are going to freak out that we have pi in the middle of an equation. Don't freak out yet. Pi times radius squared. So that's, oh, we don't know that one. Oh yeah, we don't have that one. And then pi times plus pi times r, which we don't know, times the slant height, which is 9. Oh boy, we have an equation. I know you don't feel happy yet, but there's a pi and a pi and a pi. Okay, so first of all, we have an equation. That's good. Get it equal to 0. So we've got to subtract 36 pi from both sides. Yeah, we got to subtract that. So we have here 0 equals pi r squared plus 9 pi r minus 36 pi. Okay, get it equal to 0. Check. And look at the power of this as we go. Now we need to factor it. Do you see anything common? I see a pi. Pi is common. So we factor that out. We have pi times r squared plus 9r minus 36. Now look at this. This is a trinomial leading coefficient 1. So we need to find things that times to a negative 36 and add to 9. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Look at that, negative. So negative 3 and positive 12 will work. So this is r minus 3, r plus 12, and pi out here. Alrighty, now look, we factored it. Now each piece equals 0, so we get pi equals 0. That isn't true. That's not even a real thing. R minus 3 equals 0. Gives us, well, let's go ahead and write that down in slow motion. R minus 3 equals 0 is this piece equal to 0, and that gives us r equals 3. Then the last one is r plus 12 equals 0. That gives us r equals a negative 12. Oops, not a negative 12, just a negative 12. There we go. Now, mathematically, negative 12 and 3 will both produce the exact same answer in this surface area equation. However, one of them makes no sense as the radius of a cone. So reality shoots that guy out of it, and so the radius is 3 inches. That's why the negative 12 doesn't work, is because, well, it can't work. Yeah, so if you were to stick 3 in here and a 9 there, you would have 36 pi as the surface area, and it would work. Excellent. Number 27, a triangle has an area of 14 square inches. Now notice this, we're not doing a right triangle with a squared plus b squared equals c squared. We're doing the area of a triangle, which is 1/2 base times height. And it says the area is going to be 14. That's 1/2. And it says the height, h, equals 3 inches more than the base. So it's 1/2 base times 3 plus the base. Oh boy, okay. So let's jump the 1/2 b into both of these, and we get 14 equals 3/2 b squared, b, plus 1/2 b squared. We don't like those fractions, but note we are back into the happy math land. This is an equation. We know how to deal with this. Times through by 2 to get rid of the common denominator of 2, and we get 28 equals 3b plus b squared. Okay, we have a polynomial equation. Look at that. We can do this. First step, get it equal to 0. 0 equals, let's write this in order, b squared plus 3b minus 28. Okay, 0 equals that. Good. Factor. Is there a greatest common factor? No. It's a trinomial. Leading coefficient is 1, so this is a short, quick one. B, and then we got to see what negative 28, what times up to negative 28 and adds to a positive 3. You got 1 and 28, 2 and 14, 3, nope, 4 and 7. With a positive 7 and a negative 4, that works. So we got a minus 4 and a plus 7. Great, we factored it. That's step number 2. Now each piece equal to 0. B minus 4 equals 0. And you get B equals 4. B plus 7 equals 0. And you get B equals a negative 7. And okay, so let's check now. Go back. Our original, triangle here. I don't know what it looked like, but the H was 3 plus B. Here's the B. And the area turned out to be 14. The base can't be negative 7 inches long. Reality throws that out as an option, so the base is 4 inches. And that's the answer. There we go. So we got to create an equation. It's a polynomial, so we got to get this get equal to 0 and factor it to be able to do anything. Great. Number 28, Jill has a small treasure box that is 6 inches long. So we have a treasure box here. So this is a rectangular solid when we look at the formula. So it's 6 inches long. It says the volume equals 72 inches cubed. That's good. And the width of the box, so here's the width. The width is 5 inches less than twice the height. And here's the height. Ooh, okay, so what are the dimensions of the box? We have the volume. That means we're going to be using the volume formula. And the volume is length times width times height. So length is 6. Oh, volume is 72. Length is 6. Width is 2h minus 5. And the height is height. All right. So we've got to get it equal to 0, distribute these things, jump it in, jump that in, and we get 6 times 2 is 12h. Then when you jump that guy in, it's h squared, minus 30, jump that guy in from this side, and it's h equals 72. First step, we have a math equation. First of all, be happy about that. And it has h squareds in it, so get it equal to 0. 0 equals 12h squared minus 30h minus 72. Excellent. Step number 2, factor. What has all of that? Let me see. 12? No, not quite. 6? Yeah, 6. 2h squared minus 5h minus 12 equals 0. Okay. So keep factoring. We have a trinomial here with leading coefficient not equal to 1 and not a perfect square. That means we have to do the AC method. 12 times a negative 2. Let's rewrite this up here where we have a little bit more room. We have a 6. 2h squared minus 5h minus 12. Good. 2 times a negative 12. That's negative 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. And we're trying to get a negative 5. So that'd be a negative 8 and a positive 3. Does that really times together to give you negative 24? Add together to give you negative 5. Yes, we have 2h squared plus 3h minus 8h minus 12. And we now have 4 terms. Cut that in half. Pull out the h. We're at 2h plus 3. Oh, let's do it with a different color. We're doing grouping. I forget that sometimes. 2h plus 3 makes it much more obvious for people watching. And then we take out a negative 4. And we're left with a positive 2h plus a 3. And then factor that guy out. 2h plus 3. And we get the last leftovers, the h and the minus 4 right there. Now bring everything down. This 6, was been floating out there for a while. And the other thing that's been floating out there is this equals 0. Okay, we got through step 2, which was huge. It was factoring. But when it's factored, we now can set each piece equal to 0. 6 equals 0. Yuck. Nope, does not give us an answer. 2h plus 3, let's use that color and see what that gives us. 2h plus 3 equals 0. Subtract 3 and we get 2h equals a negative 3. H equals a negative 3 halves. Okay? And h minus 4 equals 0. H equals a positive 4. So we have h equals a positive 4, h equals a negative 3 halves, or nothing. Now, let's go back. This is a real-world problem. And even though both of these numbers fit into the math equation just right, one of them does not match the real world very well. You can't have negative 3 inches, negative 3 halves inches as a possible answer. So I'm sorry, real life has thrown you out as an answer, and the answer is 4 inches. Whew. All right, number 29. The product of two consecutive integers is 89 larger than their sum. What? The product of two consecutive integers is 89 larger than their sum. There's a positive set and a negative set. What are they? Oh, wow. Okay, let's read that one more time. Let's get two consecutive integers. So we know that one of them is x and the other one is x plus 1. Okay, so that's two consecutive integers. Whether they're positive or negative, you start somewhere and then you go to the next one. So it says the product of their two integers, x times x plus 1, is 89 larger than these two guys added together. That's a math equation. We got that. The product, that's multiply, of the two numbers is 89, there's larger than their sum, the sum of those two numbers. Okay, let's simplify this out just a little bit. We have x squared plus x equals 89 plus 2x plus 1. Oh, getting closer, getting closer. Notice to solve this equation, we have an x squared, so we have to get it equal to 0. So I'm going to subtract the 2x over here. When I subtract 2x, I get a minus x, and then 89 plus 1 is 90. Subtract that over to make sure we get it equal to 0. This step is crucial. You must get it equal to 0. Then x squared minus x minus 90 equals 0. We need to factor. Is there a greatest common factor? Nope. How many terms? 1, 2, 3. It's a trinomial, leading coefficient 1, which means it's going to be nice and short, like this. So let's see what negative 90 does. You can have a 1 and a 90, a 2 and a 45, a 3 and a 30, 4, you could have a 5 and an 18. 5 times 18 is 90. 6 and a 15, 7, 8, 9, and a 10. Do any of those, with a negative on one side. Let's put negatives down there. Negative plus a positive to give a negative 1. That's our baby right there. X plus 9 and x minus 10. Ooh, okay. So this equals 0. Notice we just finished step 2. We factored that. We got it equal to 0. We factored it. Now we let each piece equal to 0. And we get this piece, x plus 9 equals 0, gives us that x equals a negative 9. This one says x minus 10 equals 0. So x equals a 10. Now notice on each one of these, I'm going to do them in different colors so we can see. This guy right here, if x equals a negative 9, then x plus 1 is negative 8. That's important. That's one set of numbers. Negative 9, negative 8. X equals negative 9 gave us one set of numbers. Even though it looks like these are kind of consecutive, they're nowhere near each other. The next set happens when x is 10. If x is 10, put that in this color. If x is 10, then that gives us x is 10, and then the next one up would be 11. Now, this warrants some checking out. Let's see if this really works. So those are our answers, I think. Let's double check that this is right. Their product, so a positive set, 10 and 11, negative set, negative 9, negative 8. And it came because x negative 9 gave us its consecutive. So the product of two consecutive integers, negative 72, is 89, positive 72, is 89 larger than their sum, which is negative 17. Is that right? 89 plus negative 17 is 72? Yes. And let's try 10 and 11 just to check and see if it works. Their product, 110, is 89 larger than their sum. Wow, 89 plus 21, in fact, equals 110. That's amazing. What a great problem.